Good morning, students. Today we'll proceed with energy, and today we'll be looking at strain energy. Okay, so the other day we were looking at gravitational potential energy, and we saw that it's a form of energy which is possessed by objects that are above the ground. Okay, so above the surface of Earth. So today we'll proceed to look at strain energy. I do believe you guys are okay with that. So let's move on. All right, let's start the definition. So how do you define strain energy? So strain energy is defined as a form of energy possessed by all elastic objects that are stretched, twisted, bent, or compressed. So these objects, first of all, they have to be elastic. That's the first thing. Then either they have to be stretched, twisted, bent, or compressed. All right, so if you talk about stretching, think about a rubber band or an elastic band. You know, when it's stretched, it simply means it has strain energy, okay? If it's twisted, think about a plastic ruler, okay? It can be slightly twisted or bent, the same ruler, or compressed, okay? Compressed, think about a spring, okay? A spring can be compressed. Or squashed, think about a balloon with air inside. Now, examples of elastic materials, we have elastic band or rubber band, okay? You know, when you talk about elastic materials, you talk about materials which, when you pull them apart and then you release them, they can go back to their original shape. Okay, so that's, if you bend them and you release them, they can go back to their original shape. Those are called elastic materials. So you also have a plastic ruler, okay, because when you bend it and you release it, it goes back to its original shape. Therefore, it means it's an elastic material. And also a metal spring, when you stretch it and you release it, you know what it does? It goes back to its original shape. All right, now let's go back to your book, Checkpoint Science Book 1, page 217. It says, strain energy is also called elastic potential energy. That's exactly what I said. Some materials can be easily squashed. Okay, so squashed, you talk about like a balloon. Stretched or bent. Stretched, you talk about elastic band, or bent, you talk about a ruler. But spring back into shape once the force acting on them is removed. So, for you to know that this material is elastic, it simply means when you squash it, or stretch it, or bend it, it should spring back into shape. So the word spring back, that's a phrasal verb, I guess, meaning to say goes back into its, not a phrasal verb, spring back, it's a verb, I guess, spring back. So it goes back to its original shape once you release the force which was stretching them, squashing them, bending them, or compressing them. So they are called elastic materials. When their shape is changed by squashing, stretching, or bending, they store energy which will allow them to return to their original shape. Okay. Now, it means when you stretch the material, or when you bend them, or you compress them, whatever it is, that's when they have the strain energy. And this energy is the one which allows them to return to their original shape. A spring stores energy when it is stretched or squashed. Gases store strain energy in them when they are squashed. For example, when the gas used in an aerosol is squashed into a can, it stores strain energy. Do you know what an aerosol is? Okay, an aerosol can, I'll talk about an aerosol can, is a container which, when you press on it, a jet or a stream of liquid comes out, splashing out so quickly. A good example is a perfume bottle. So in the morning, before you come to school, you're like, oh, let me put on some perfume, let me wear some perfume, and you go like, tss, 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 tss. That's an aerosol can, because when you're pressing on the top, there is a liquid coming out, okay, spraying out, yeah. All right, so they're saying that when the gas is used in aerosol, it is squashed into a can, it stores strain energy. So when the liquid is put into, when a liquid or a gas, just depends on which one you're using. So I think this time they're talking much about a gas, so let's focus on the gas. So when you take a gas and put it in an aerosol, it has to be compressed. See that? And it's even called compressed air or compressed gas. and then it has strain energy. Some of this is used up when the nozzle is pressed down, and some of the gas is released in the spray. Okay, so it's a spray again. So when you press on the nozzle, when you press it down, so the nozzle will open a channel to where the gas can come out. Examples: number one, which of the following have strain energy in them? A squashed balloon. Does it have strain energy or not? Yes, it does. It's a squashed balloon. You see, it's compressed and it has air inside. An elastic band. An elastic band has no strain energy unless it is stretched. So it means, for the meantime, just by riding an elastic band, I'd say it doesn't have strain energy, only if it is stretched. Okay, let's go to C. A bent wooden ruler. A wooden ruler. If you bend this one, I think it will just break. I don't know. I've never tried to bend a wooden ruler, but I just feel like it's too brittle to be bent. No, maybe I think we should do an experiment on this, but I just feel like wood is not elastic. Therefore, maybe it would just break. Okay, let's go to a compressed spring. Yes, it does have strain energy. Now, let's take this further to a past paper question from 2016, paper 2, question 2. It says, figure 2.1 shows a spring before and after a load is added. You see, that's what they say. State what is meant by the term, or state what is meant by the extension of a spring. Now, I have put two answers here. I want you to pay attention to that. You see, the first answer is that extension can be defined as increase in length, as simple as that, increase in length. Or you can choose to say extension is the new length minus original length. Both are correct. Just write one out of that, you get it correct. So just choose one there. Okay, just choose one right there. State the form of energy possessed by the spring when it is extended. Strain energy. Yes, it's strain energy. All right, more examples. It says, state the form of energy possessed by the following. A twisted plastic ruler. Okay, so it's strain energy, as you can see. A book on the table. That's gravitational potential energy. Then you have a compressed balloon. That should be strain energy. Then you have an apple in the tree. That should be gravitational potential energy. Right, and that seems to end the lesson. Otherwise, all the best. See you in the next lesson.